Welcome everyone to this third webinar in our Introduction Series Advanced Reinforcement Modeling. My name is Monica Rennick, and I'm the Senior Technical Consultant for ALLPLAN. I graduated with a Bachelor's in Civil Engineering from the University of Illinois. I have over 12 years of experience in the industry. 5 of those were consulting in and around Chicagoland, and I've also spent several years working for an engineering software program, providing technical assistance, training, and consultancy in using the programs. Today I'm going to go over a brief introduction, then we're going to jump right into the program looking at advanced geometry, how we can reinforce that geometry, and we'll go through a full building example. Finally, we'll look at generating drawings, schedules, and reports, and at the end I'll briefly introduce you to our company, and then we'll have plenty of time for Q&A. As a brief introduction to what we're talking about today, I want to show you a few examples of how customers are using ALLPLAN for their various jobs and structures. So here you can see some pretty complex rebar detailing jobs where the 3D visualization really comes in handy. And here's just a few building projects that have been done, anything from housing complexes to high rises and stadiums. Now, an area where we're really getting the most feedback is bridges. ALLPLAN is a great solution for bridges and roadways. And recently, we're hearing more and more from the heavy civil side. We're looking at tunnels, water towers, dams, and buried structures. So hopefully we have a little bit here for everybody based on our audience today. So as we're going around and meeting with engineers, this is the basic process that we keep hearing about. Once the engineer gets a project, they spend their bulk, or hopefully the bulk of their project budget of man hours on the design of the project. Then we spend maybe a bit less, maybe it's a bit more or equal to the modeling and drawing creation. Of course, there's time for coordination, and this could be with the architect, other disciplines, the contractor, etc. And most likely this adds more time to the design and the drawings as well. Then we've spent some time on the shop drawings, either reviewing or you could be the ones that are generating them. And finally, it seems there's always some field issues that we have to deal with. And again, this could result in possibly more time on the design and the modeling side. But what if we could shave off some of the time that it takes for the coordination, the shop drawings, and the field issues without increasing the time on the modeling and the drawings? Most of the time when we pose this question to our customers, it gives them some time to take a step back, think about it, and say, okay, yeah, I think if we could do a little bit more on the drawing side, but not necessarily add more time to our budget, but be able to shave some time on the back end, that could be of some value. So that's what we're really talking about today. So here's a word cloud to help illustrate what it takes to reduce time on those final 3 project phases, and the key here really is accurate BIM modeling and rebar modeling. So just keep that in mind as we're going through our examples today. One little caveat here, the drawings are still extremely important for the success of our project. So many BIM programs are focusing on the 3D model alone, but the documentation is tedious or incomplete. And the reality is our industry still very much uses 2D drawings in the field, and in order to maximize schedules and budgets, we need to produce quality documentation. So let's start by taking a look at some modeling examples. And the purpose of this webinar, or for the purpose of this webinar, I've recorded some examples, and I'll just go through them here with you today. So here we start with a very simple retaining wall. The strength of ALLPLAN lies in our 2D to 3D workflow. We can take any 2D drawing that you create and quickly turn it into a 3D structure. Notice that the wall doesn't have to follow a straight line, so it can accurately represent whatever curve the final product is going to follow. That means I can define the path of my wall. I can then rotate it freely in 3D so that it's accurately facing up. And then using the extrude along a path command, I can quickly extrude this profile so that it now creates a nice smooth 3D shape. And you can do this with any 3D structure that you need. You can see if I turn on the animation, it looks very nice with the smooth lines, the smooth curves. You can render this, you could give this drawing to a customer, and as we're going to see in a later example, we can then fully reinforce it. Now, my background specifically is in buildings, so you're going to see a lot of building bias in today's presentation. But here's a bridge pier to show a little bit of example of something different and some of the extrusion and modeling capabilities. I'm sure a lot of you are already familiar with these commands, especially if you've used solid modeling tools in the past. So we're not really reinventing the wheel here. We're introducing a faster, more aerodynamic, and cost-effective wheel. And the beauty here is that the loft tool gives a nice smooth finish, and it can be used to really generate any shape. We can chamfer any of the shapes to give a realistic, accurate description of what the building's going to look like, or the pier in this case. And what's really nice is we can also add textures and surfaces, so this could actually look like the finish that you're going to produce. And again, this could be sent to the client, or it could just help with better visualization. The next example is probably a bit of a niche subject, but again, you can see the power behind the modeling. Here we can take a simple circle and turn it into a solid volume that can then be fully reinforced. Our motto is really, they can dream it, you can model it, and we can reinforce it. Now, originally I had envisioned this as maybe a museum or a stadium, but the more I think about it, this concept could also be applied to water towers, domes, tunnels, so a variety of different projects where maybe you need something a little bit more complex than just a box. Once that circle has been converted to a solid shape, we can then make it into a volumetric shape, so we can add a thickness to it. And we have all sorts of different kinds of tools that can help. Is this thickness going to be defined from the top, from the center, from the bottom? You can change the thickness, whatever it needs to be, and you can create a nice, smooth, circular, basically any type of surface. Now in this example, the sweep command allows us to create a solid shape that is bending in two directions as well as growing and shrinking. We can define as many segments as we need for the different shapes that the structure is going to pass through. Then selecting the profiles and defining a path, the program will generate an accurate 3D solid with a double curvature and different heights. So I want to ease us into the reinforcement project and first show a couple examples that you can hopefully extrapolate out and see how it can be applied to a wide variety of situations. Here we're going to quickly reinforce this polygon. This could be a retaining wall, an abutment, whatever it is, we can define the reinforcing for it. You'll see a typical workflow is that we really define several sections and profiles of whatever it is that we're going to reinforce, and then we use those to reinforce the section. We have several built-in rebar configurations that you can choose from to start off the detailing, and there are also freeform options available. The program can identify the extent of the structure that you're detailing, so the bars will expand or follow the outline of whatever it is that you're reinforcing. Within these shapes, we can also define the concrete cover, and you can change the cover to be different on each side or have it be the same for all sides. So there's really a lot of options to be able to model this how it needs to be. ALLPLAN also has special placement tools that allow you to define a polygon to reinforce. So just by outlining the shape of the polygon, it tells the program the extents that the reinforcing is bound by, and it can then fill up and through that shape. Once the polygon has been defined, the command also gives several options for the reinforcing in general and how it's going to be laid out. So you can change the bar diameter, you can change how it's going to be laid out, the spacing, all of this can be done through nice little input wizards, and then we're also going to have options to change that information later. Once the input boxes have been confirmed, the program will automatically generate the reinforcing based on those inputs. We can choose to display a single bar in the sections for clarity, but we'll see in a second that the reinforcing is complete in the 3D view. Now, everything here is parametric, and this is where the IM or information modeling in BIM comes into play. The reinforcing has actual information associated with it, so we can add intelligent labels to the section drawings with several options for what specific information you want shown. Notice the stirrups are increasing in height to follow the polygon. Now we can make changes if needed. For example, we can stretch the shape and the reinforcing will move with it. We can also select different bar sizes and the diameters of the bars will update. And you can change the spacing in the properties window to update automatically in the drawing. Let's go back to that retaining wall along the curve, and now we can add some reinforcing to it. We have several built-in rebar configurations, again like we saw in the previous example, and the program is going to identify the extents of the structure that you're detailing. So the bars will expand or follow the outline of whatever it is that you're reinforcing. And like we saw in the previous example, all of the information about the bars is stored within the program, so we can easily change between the bar diameter, the spacings, and we can really define all of this information as we're modeling the reinforcing. Other than these tools to help make the process a bit easier, this general workflow should be pretty similar to what most of you are doing now. Notice that I'm in a 2D workspace. I'm using basic modeling tools to draw out the bars. So we're just adding in circles, we're using the copy command, we're mirroring. All of these things are typical that you're probably doing right now for drawing out your details. Moving into BIM and a 3D workflow can be pretty intimidating, and there's this stigma that there's going to be a huge learning curve. And really, what we're doing by introducing ALLPLAN is that we're telling you that that's not necessarily the case. We can introduce a 3D workflow and all of the benefits that are associated with it and not have this headache, this huge learning curve, all this time it takes to get you up and running. We're incorporating what you already know and giving you all the advantages of the 3D workflow. And now you have the added bonus of using tools like the extrude along path command to generate actual 3D rebar from that 2D line work. Here again, I can select the reinforcing that I want to extrude and then define the path or that spline that it's going to be extruded along. And notice that now I can actually add different stations along the reinforcing. So I could say maybe at the end of the wall I need a tighter spacing, and then in the middle of the wall I can have a different spacing. And so all of that is customizable and it's all automatic and parametric. So we can just add that information as needed. And then I can go through, select the different bars, this time the transverse bars, and I can again define my path, and we'll see that those are automatically created and they're turning and expanding along with the wall. Now I'm going to do the horizontal bars. Again, you can see that they're following that path exactly. And in this case, we can also add an extension. So if you need to extend the bars past the wall, so if they're going to maybe tie into some other framing that's coming in the future, you can extend those bars and accurately display that. And so if we zoom in here a little bit, you can see all the reinforcings in there. So for little to almost no additional work, we can have a really accurate, fully reinforced, complex wall. Here's our double curved wall that we modeled earlier. Now for this type of wall or this type of condition with the double curve and the expanding height as well, we have to actually cut a few sections along the path. And this is to tell the program how the reinforcing is going to change throughout the different points of that curve. So there's a little bit more work in that aspect, but really you would have to do that anyways as you're defining the different sections along the wall. So now all I have to do is select the reinforcing in each of those profiles and then again define the path of the reinforcement. In this case I have to click on 3 areas because it's changing in multiple ways. It's not a single path like it was for the previous example. And notice that the reinforcing is correctly following the curve, it's bending, it's expanding, and we're really able to get an accurate representation of what the reinforcing is going to have to do to go into this complex wall. And again, everything's parametric. So here I can change the spacing between those bars. If you notice, I have a stirrup and then kind of a longer bar there, so we can change the spacing between those. And we can really make a lot of changes in order to accurately demonstrate what this wall is going to look like. Now we can also sweep the horizontal bars, again defining the path that they're going to go across. And you can see that those are also following the curve, kind of increasing a little bit in the middle as it gets taller and going back to where they started. And here, like we saw for the retaining wall, we can add an extension at the ends. We can define what that length is, so we can get an accurate bill of materials and actual rebar lengths as well if we're really concerned about the rebar detailing. This is going to be our final example for today, and now we're going to get into a full building example. So an actual project where we can look at what some of the workflows are and some of the ways that we can reinforce this building. So I've done a little bit of it already. You can see I have some reinforcing in the footings and the piers. I also have some wall reinforcing. It might not be complete, but it's pretty much all there just so we have something to start with. And what I'm really going to focus on next is going to be in doing the slab. So we're going to spend a little bit of time on the slab reinforcing, and then we'll kind of move into reports and drawings. So we have some really great tools for laying out very quickly the area reinforcing in the slab. And we have this area detection command that you simply click in a polygon and it automatically detects where that polygon is, and it knows the extent of where it's going to apply that reinforcing. So this is great if you just have a base reinforcing, let's say in the bottom of the slab. You're going to have number 5s at 12 inches on center, and you can quickly lay that out. And we can also add openings in the same way. We're just defining that there's a polygon here, it recognizes it, and it puts in an opening in the slab. Now in this dialog box, I can indicate what my rebar size is. It's going to do the right dimensions in the drawings, the rebar lengths, the lap splices, and all of this is also built in based on ACI. So it is going to calculate accurate lap splices for you. We can also define how this is going to be represented. And along the edge here, this is really nice. We have this benching command. So you can either say no benching, the bars are going to go right up to the edge, or you can define a benching and you can define a horizontal or vertical distance, and then it will be actually cut back the bars to maybe something more accurate of how it's actually going to be built. And this might be something that a rebar detailer might be a little bit more interested in. You can also change, you just saw that screen, of how the different ends of the reinforcing are going to look if you need to have a hook or different types of bends at the ends of the bars. Once you exit out of that input screen, we can now start labeling the bars, and there's lots of different ways that you can choose between how it's going to pick the labels, how it's going to define the spacing and that distance, and then also what information is going to be shown. So do you want a mark number? Do you want the number of bars, the size, the spacing? And then you can just click on those and lay it out, and the program's actually walking along the model and prompting you for the different sections. And once this is laid out, you can also go back and make changes. So if you decide you want to show more or less information, or if you don't like the dotted line, you want a solid line. If you don't want it curved up like that, you want it straight. All of those are completely customizable. You can change them. You can have it look the way that you want it to look for your really nice completed documentation. Now, one thing is this can get a little bit busy with all the bars, so we can also choose to show just the center line bar, and that way we don't have to show all of the bars in the drawing. Now, maybe at the end here where it curves, maybe there you want to show every bar so that it can be a little bit clear of what's actually going on. Now, in order to do the reinforcing in the other direction, all we have to do is simply say it's a match. So I'm saying, hey, base it off of what I've already done, and the program automatically rotates the bars and recognizes where it's going to lay it out. So we don't need to do all the different area detections again. And this time I can say, you know what, let's just show the bar in the middle. And now you can see as I'm adding the labels and kind of detailing around it, it's automatically switching it to show just the center bar instead of showing every single bar. And this is all based on personal preference, how you want to detail, what steps you want to take. So just showing that there's a lot of different options as you're working through this. Now I'm only going to detail a little bit of it just for the purpose of our conversation. And then I'm going to go ahead and just show the centerline bar for the bulk of the reinforcing here so that we can take a look at some of the other areas of the building in detail a little bit further. So this is not going to be fully 100% detailed to what you would deliver, but it gives you an idea of what you can do and how far you can take it. So I don't even have to detail everything again. I can just kind of stop and then say, hey, for these bars here, I don't want to show everything. I'm going to modify the placement. You can do this sort of thing at any time and then just click on the different sets of bars and it will show just the centerline bar instead of every single bar. But notice in the 3D shape on the left side there, it is always showing all of the bars. So now I'm going to add some edge reinforcing. So this could be, maybe something that goes into the wall below, some edging that has to come perpendicular from that slope there. So I'm going to define that edge. I'm going to tell it the direction that the bars are going to go. And then again, everything is defined in the input boxes. I can say what my cover is from the bottom of the slab, what the bar diameters are, and then the length of how far those bars are going to extend into the slab. So that one you do have to define because that's just up to what you need for that anchorage there. And so you can see once I put it in, I can also change the spacing. And then in this case, I'm just showing the centerline bar. I'm adding in my dimension line and the label. Now the final thing that I'm going to do as far as in the slab is show how we can then go back and do some top reinforcing. What I'm noticing more and more, at least on the building side, is that people are really taking advantage of an FEA analysis and just placing the reinforcing where it needs to go. And so this is kind of the application that I'm using, kind of the strategy that I'm going for here. So let's say a 4-foot window around the column. All I have to do is click on the ends of that column to define the extent of that window. And then I can go ahead and put in where these bars are going to go. What's my clear cover now to the top of the slab, not the bottom of the slab. The program will automatically place those correctly within that slab. And once I say OK, I can change the rebar size and the spacing, and it will automatically lay out those bars for me. Now in this case, I want to show all the bars just to make it clear on the drawings. And then I can go ahead and add the dimension and the label mark. And again, the dimensions and labels, those are totally customizable to how you want it displayed in your drawings. I'm going to use the match command again, similar to what we did in the bottom reinforcing. I just have to click on one of those bars. It will recognize all the previous information I input, but I can still make some changes if I want to, but it automatically rotates the bars and adds them into that same area. And now I can have my top reinforcing. I can label it, add my dimensions, and then you can either copy this to the other columns if you have similar reinforcing, or you can very quickly step by step do it on the other columns if the reinforcing does change or is different. So there's lots of ways that you could do it. Copying might be easier because you can always go back and change the reinforcing after it's been laid out. So you can see here in the 3D view, there's all of my reinforcing, and you can really see how it's coming together. In a large project, it can get pretty crowded pretty quickly. And this is something that I've heard a lot of customers talk about, that they want to be able to see, what does 12 number sixes really look like? Is there actually space in there? Is it feasible to construct this? And that's where the 3D representation really helps, really comes into play, is are you creating something that's going to work in the field? And sometimes that can be hard to visualize when we're just putting in words and not really drawing everything to scale and actually modeling it. So now I'm going to go ahead and create a report. There's lots of different types of reports that you can create. We have some out-of-the-box ones like this one here that I'm showing you, but you can create your own as well with whatever information that you need. Another really nice feature is that you can bring in a bending bar schedule and you can put that right on the drawings. So you can select from a list of different options. You can add those there, and these are going to accurately represent what you've modeled. So all the dimensions, all the bar layouts, everything is based, and it's also automatic. So if you make changes to the drawing, this schedule will automatically update as well. Now let's get into a little bit of the layouts, and this is really important. Again, like I mentioned before, we have to have great, accurate drawings that are going to represent our intent and make sure that the processes down the line are as smooth as possible. So the border, all of the logo, all of the stuff on the drawing itself, totally customizable. You set that up in your template, and that way for every project, it is the way that you want it. I think that's pretty standard and everyone expects that. But on top of that, we have the ease of putting in whatever drawings, whatever sections, elevations, information from the model that you want into these drawing files. And again, everything's kind of tied back to each other. So if something changes, this will update. And we also have the flexibility to draw on top of the drawing files themselves. I do recommend drawing in the model because sometimes that just keeps everything a little bit cleaner, but it's really up to you. And if you need to add something last minute, if you need to make changes, you can do all of that directly on this layout. So now I'm going to do another drawing file, and this time I'm going to look at the foundation. This kind of gives you a little peek at what our drawing file system is. And we really do operate on based on drawing files, and the benefit of that is that the size of the project is going to be small. So you're not going to have this gigantic file that takes a really long time to load. It also means that multiple people can be working in the project on different files. They can see each other's work and they can really collaborate. So that's another really nice feature. So one of the strengths of working with this system is that we can now take section cuts, different elevation views, side views, section cuts of the project, and everything is linked and everything is live. So if I take a section cut of this footing, if I later make a change to that footing or the reinforcement of that footing in the model, that's going to automatically update my sections. So for those of you that might still be working more in a traditional AutoCAD environment where you're probably doing all of that manually, hopefully you can see some real time savers there in having everything linked. So I'm going to go ahead and just do the same thing, but now for my wall shaft here, maybe this core wall, I just want to show some information there. So I can take just a quick plan section of that, and then I can do an elevation of the wall. If you want to show an elevation of the reinforcing of the wall, I know I've seen that a lot in customer drawings. And of course, this is a little bit primitive, but you can have some more different bar layouts, some different overlaps. You can fully detail it so that it looks correct, ready for construction. And then we'll do a section there as well. Now, the sections here I'm doing are just pretty basic straight section cuts, but you can also do sections that are jagged, that follow any path that you need it to along the building. You can also do a section cut that follows a spline. So you can do like a section along a curve. So that could be really helpful, especially for bridges. If you get into that, there's lots of different ways that you can use that command. So this drawing file structure, this is for the layouts, and that's again something you can do in your template, have it ready to go. And now I'm just going to add those drawing files. So first just an overall plan of the foundation and that first floor. You can set the scale factor to whatever it needs to be. And then you can go in and add the detail drawings underneath it. Now the detail drawings can be in their own file, but here I just want to show you that you can combine them any way that you want to really get the best drawings that you need so that you can accurately and properly show how everything comes together so people know how it's going to be built. And like I mentioned, everything's parametric. So let me go back now, and I'm just going to add some annotations to the wall. And remember that these are actual modeled rebar sections. So the program knows what size it is, how many there are, the bar mark number. And so I can simply just say, let's go ahead and add a label now. I click on the bar and it inputs all of that information. So I don't need to go back and figure it out or count it or keep track of it. The program's keeping track of all of this information for me. And these are just drawing files. Really, I can just lay these out any way that I want. So I can just use a simple move command and just kind of shift everything over to the side just so that it looks a little bit neater. Again, all of that is up to you. You can set that up ahead of time in a template. You can have a grid system if that's how you prefer to show everything if you need to. Okay, so that's basically the building example. Hopefully everyone saw some benefits there. I'm going to very quickly just talk about Nemetschek now. This is the mothership, if you will, the company that owns us. And it's really just to show you that we're backed by a very large global company, that there's a lot of money, a lot of resources that are going into this. So you're not potentially going into this no-name brand new product that is kind of all on its own. So we have a large backing and a lot of significant resources to continuing to expand and grow and improve this product. So now what is the product? We haven't really, I've kind of alluded to it. It really is called ALLPLAN, and this is a BIM product, a 2D and 3D modeling tool. We're introducing it to the US market, so it's brand new to the US. So if you haven't heard of it before, that's why. However, we have existed for a long time, and it's widely used and actually one of the leaders in Europe. So in Europe, this is we're a software leader there, and they said, you know what, why are we only keeping this in Europe? Let's expand to the US market and show the US engineers that, hey, there are other options out there for you if you want to get into BIM. You're not restricted just to the couple of products that are out there right now. And I think I kind of went through it quickly, but we have lots of different partnerships and different companies that are also under our Nemetschek umbrella. Some products you might remember like Risa and Bluebeam. Okay, so let me just go over some of these case studies just to kind of show you some real world examples of people that have used ALLPLAN. Again, these are all European projects because we're brand new to the US market. So this is the Queen's Ferry crossing in the UK, and you can see from the pictures that it's extremely complex. There's a lot of detailing going on, and they really needed to have a 3D solution in order to visualize how everything was coming together and put it all together. Now this one is the Tamina Bridge project, and what I like about this one is that it shows the post-tension tendons in the bridge. I wasn't able to get to tendons today. There's just so much information I wanted to show you all, but that's something that we can, again, easily do. We can model the tendons exactly, put the kind of caps or whatever those are called at the ends, and that's something that we can do in ALLPLAN as well. And then we have this water tower project in Budapest. And now this one was really unique because they needed to construct it in a specific way. So the phases were very important because once the inside was done, they couldn't get back into it, just because of the way that the construction was working. So they really had to know when each thing was going in. And that's the beauty of ALLPLAN, is that we have the ability to work with layers. And so you can also add phasing to the layers, and you can really see, okay, layer 1, this is what you're going to look like, and this is when you're going to go in, layer 2, layer 3, and it can really help to visualize the construction process. So that's what they really used on that project. We do have additional resources available on our website, tutorials, resources, connect.allplan.com. We also have a free trial that you can go and check out. If you have any other questions or would like more information, please feel free to contact us. There's our email address there. And I'll just wrap this up with my contact information there on the screen. Thank you everyone for participating today. We really appreciate you taking time out of your busy schedules, and I hope that you all enjoyed the webinar and found it very informative. Thank you and goodbye.